Good morning children. In previous class we had learnt how to balance the chemical equations. Okay. In today's class we will learn types of chemical reactions. Okay. There are five types of chemical reactions. First one is combination reaction. Second one is decomposition reaction. Third one is displacement reaction. And fourth one is double displacement reaction. And the last one is oxidation reduction reaction. Okay children, we will learn one by one. First we will learn combination reaction. Combination reaction. Okay. The reaction in which a single product is formed from two or more reactants is known as combination reaction. Okay. The reaction in which a single product is formed from two or more reactants is known as combination reaction. Is known as combination reaction. See here, the reaction in which a single product is formed from two or more reactants is known as combination reaction. Here, two or more reactants that combines to form single product. This reaction is also known as synthesis reaction. Synthesis reaction, because here by the combination of two or more reactants, new single product is formed. Therefore, this is known as synthesis reaction. Okay, or it is also known as composition reaction. Composition reaction. Okay, or we can also say that addition reaction, because here two or more reactants on adding they will form a single product. Okay, let us see examples for the combination reaction. See here, this is calcium oxide. This is calcium oxide. Its common name is quicklime. Its common name is quicklime, whereas its chemical name, okay, it is calcium oxide. It reacts with water. It reacts with water to form calcium hydroxide solution. Along with formation of this calcium hydroxide solution, here heat energy also released. Heat energy also released. this calcium hydroxide, calcium hydroxide is the chemical name. Slaked lime is the common name of this compound. Okay. See, this is calcium oxide is taken in a beaker. To this beaker, if we add water, okay, it reacts vigorously with the calcium oxide and it will form calcium hydroxide. Along with this, here heat energy is released. Huge amount of heat energy is released. Okay, see here this calcium oxide is one reactant, whereas this water is another reactant. These two reacts, okay, and they combines to form a single product, calcium hydroxide. Along with this, heat energy also released. Okay, here this calcium hydroxide, okay, it is used for whitewashing. This calcium hydroxide is used for whitewashing of walls. Okay, it is used for whitewashing. This calcium hydroxide, it reacts with carbon dioxide present in the air to form calcium carbonate. Okay, it reacts slowly with the carbon dioxide which is present in the air and it will form calcium carbonate. Okay, on formation of calcium carbonate, okay, the walls of the walls gives shiny finish. When calcium carbonate is formed, walls will have shiny look. Okay, actually this calcium hydroxide, or slaked lime is used for whitewashing. Okay, this calcium hydroxide, it slowly reacts with the carbon dioxide which is present in air and it forms a thin layer of calcium carbonate on the walls. Okay, as a result of formation of this calcium carbonate, walls will have shiny look. Okay, in our day-to-day life we can observe that. Okay, in villages, in most of the villages we found whitewashing. Okay, so those walls they have bright white color. Okay, that bright white color is due to this formation of calcium carbonate. Okay, this is one example. I will see one more example, that is burning of coal. Okay, usually coal contains carbon. Okay, it is a solid. In coal, carbon is present. Okay, so it reacts with the water, not water, it reacts with the oxygen present in the air and it forms carbon dioxide along with the release of huge amount of heat energy. Okay, see here, this coal is burned in presence of oxygen which is present in the air to form the carbon dioxide. Along with the formation of this carbon dioxide gas, huge amount of heat energy is released. Okay, usually coal contains carbon, therefore I have written here C. Okay, it is solid. This oxygen is a gas. See here also, two reactants on reacting, they will give single product. Okay, therefore it is an example for combination reaction. We will see one more example, that is formation of water hydrogen gas reacts with the oxygen gas. Okay, and they will form water. Okay, here also this hydrogen gas reacts with oxygen to form water. Here this is one reactant and this is another reactant. Here two reactants on reacting, they forms a single product. Therefore, it is also an example for the combination reaction. Okay, children, here we observe that in this example and in this example, okay, we observe that heat energy is released. Okay, so here, see here, most of the combination reactions are exothermic reactions. Then what is exothermic reaction? Okay, we will see in detail exothermic as well as endothermic. First we will see exothermic reaction. The reaction in which heat energy is released. The reaction in which heat energy is released is known as exothermic reaction. Okay, you remember the activity 1. Okay, in activity 1 we burnt magnesium ribbon. In presence of oxygen gas to form magnesium oxide, along with a huge amount of energy is released. Okay, in activity, remember the activity 1, in that when magnesium ribbon is burnt in presence of oxygen, it burns with dazzling white flames. Okay, to form magnesium oxide. Okay, here the energy is released. Here heat energy is released in this reaction. Okay, it is an example for the exothermic reaction. Magnesium on reaction with oxygen. Okay, it burns in presence of oxygen to form the magnesium oxide, along with here energy is released, heat energy is released. Okay, therefore it is an example for this combination reaction. See here, magnesium and oxygen, they are the two reactants. On reacting, they forms a single product, magnesium oxide. Along with this, they will here heat energy is released. Okay, therefore it is an example for exothermic reaction as well as it is an example for the combination reaction. As I told, combination reactions are exothermic reactions. Okay, these combination reactions are accompanied by energy release. Okay, they are always accompanied by energy release in the form of heat. Okay, now we will see one more example for exothermic reaction, that is burning of methane. Okay, CH4. It is the chemical formula of methane. It is burnt in presence of the oxygen gas to form carbon dioxide gas and water, along with the release of heat energy. Okay. Okay, this is burning of methane. It is also an example for the exothermic reaction. See here. Here this methane reacts with the oxygen, or it is burnt in presence of oxygen to form carbon dioxide and water. Along with the formation of these two products, here heat energy is released. Okay, it is an example for the exothermic reaction. Okay, it is an example for exothermic reaction, but it is not example for the combination reaction, because here two reactants on reaction, they forms two products. Okay, actually we know that combination reaction is one in which a single product is formed from two or more reactants. Therefore it is an example for the exothermic reaction, but it is not an example for the combination reaction. Remember this. Okay, we will see one more example, that is respiration. respiration in living beings. Okay, usually respiration in living beings. Actually, this respiration is different from the what we say, that is inhaling of oxygen and exhaling of carbon dioxide. Okay, in respiration process, this respiration takes place in tissues. Okay, this respiration reaction or process takes place in tissues. Here, glucose, it is the glucose solution. Okay, C6H12O6 is the chemical formula of glucose. It is oxygen. When glucose reacts with the oxygen, it forms carbon dioxide and water. Along with this, energy is released. Okay, see here, in cells what happens, this glucose is present in the form of solution. Therefore here I have written aqueous. Okay, this aqueous solution of glucose reacts with the oxygen. Okay, this oxygen is obtained through the respiration process. Actually, intake of oxygen and output of carbon dioxide. Okay, during this process we are taking the oxygen. That oxygen is utilized to break the glucose into carbon dioxide and water. Okay, here this glucose breaks into carbon dioxide and water in presence of this oxygen. Along with formation of these two products, here energy is released. Okay, therefore respiration is also respiration in living beings is also an example for the exothermic reaction. It is also an example for the exothermic reaction. Remember that it is not example for the combination reaction, because here two reactants, they reacts to form again two products. Here a single product is not formed. Okay, remember the definition of a combination reaction. The reaction in which a single product is formed from two or more reactants is known as combination reaction. But here two products are formed from two reactants. Therefore, it is not combination reaction, but it is an example for the exothermic reaction. Here, this glucose breaks into carbon dioxide and water in presence of this oxygen, or when this glucose reacts with this oxygen. Okay, it is actually it is this reaction. This whole reaction takes place in tissues. Okay, on reaction they form carbon dioxide. Okay, it is in the form of solution. Okay, carbonic acid. After this release of carbon dioxide, this carbon dioxide is converted into carbonic acid. Okay, next, along with this, water is formed here. Along with this formation of these two products, energy is released. Okay, this is all about the one more thing. This is all about the exothermic reactions. Okay, we studied exothermic reaction. Now we will know what is endothermic reaction. Endothermic reaction, the reaction in which heat energy is absorbed. The reaction in which heat energy is absorbed is known as endothermic reaction. Okay, example for the endothermic reaction, that is formation of carbon disulfide. Okay, it is carbon is a solid. When it reacts with the two sulfur atoms, sulfur is also solid. Okay, they will form carbon disulfide. This is carbon and this is sulfur. Here carbon reacts with the sulfur to form the carbon disulfide. Again, okay. So see the differences between exothermic and endothermic reactions. In exothermic reaction, heat energy is released, whereas in endothermic reaction, heat energy is absorbed. Okay. Now we will move on to next type of chemical reaction. That is second one. Decomposition. Decomposition reaction. Okay. The reaction. What is decomposition reaction? The reaction in which a single reactant breaks down to form simpler products. It is known as decomposition reaction. Decomposition reaction. See here once again, the reaction in which a single reactant breaks down to form simpler product is known as decomposition reaction. Okay, this decomposition reaction is also known as decombination reaction. Decombination reaction. Okay, this decomposition reaction is exact reverse of combination reaction. Because here in decomposition reaction, this one reactant breaks down to form simpler products, two or more simpler products. But in what happens in combination reaction, two or more reactants reacts to form a single product. Okay, now we will see examples for the decomposition reaction. Example, decomposition of calcium carbonate. Okay, this is calcium carbonate. It is a solid. Okay, carbonate. It is also known as limestone. Okay, then this calcium carbonate is heated. Here this triangle will represent heating. Okay, this triangle will represent heating. When this calcium carbonate is heated, it forms calcium oxide along with release of carbon dioxide gas. Okay, this is calcium oxide. It is also known as quicklime. Along with this, carbon dioxide is formed. See here this calcium carbonate, it is a single reactant. When it is heated, this is calcium carbonate. Okay, it is a single reactant. When it is heated, it decomposes or it breaks into two or more simpler products. This is calcium oxide and this is carbon dioxide. Here this calcium carbonate breaks down into calcium oxide and carbon dioxide. Okay, here heat energy is absorbed. Okay, therefore these decomposition reactions are most of decomposition reactions are endothermic reactions. They are endothermic reactions because these reactions are initiated by absorbing the heat energy. When they will absorb the heat energy, then only this reactant breaks down into simpler products. Okay, there are further this decomposition reaction. There are different types of decomposition reaction. Okay, first one is thermal decomposition. Second one is photochemical decomposition. And third one is electrodecomposition. Electrodecomposition reaction. Okay, there are different types of decomposition reaction: thermal decomposition reaction, photochemical decomposition reaction, electrodecomposition reaction. See here, in thermal decomposition reaction, decomposition of a substance takes place by absorbing the heat energy. Okay, but in photochemical decomposition reaction, this decomposition of a chemical substance takes place by absorbing the light energy. Okay, in electrodecomposition reaction, decomposition of a substance takes place by absorbing the electric energy. Okay, now we will study in detail. We will study the types of decomposition reaction. Okay, first type is thermal decomposition reaction. Okay, the reaction in which chemical compound breaks into simpler products by absorbing heat energy is called thermal decomposition. Reaction. Okay, the reaction in which the chemical compound breaks into simpler products by absorbing heat energy is called thermal decomposition reaction. We will see the examples for thermal decomposition reaction. Okay, that is decomposition of the calcium carbonate. Okay. Here, this calcium carbonate breaks into carbon dioxide and calcium oxide on heating. Okay, this calcium carbonate, when it absorbs the heat energy or when it is heated, it breaks into calcium oxide and carbon dioxide. Okay, here this reaction is initiated by absorbing the heat energy. Here this reaction takes place due to the absorption of the heat energy. Therefore, it is an example for the thermal decomposition reaction. We will see one more example, that is decomposition of lead nitrate. Lead nitrate. What is the chemical formula of lead nitrate? PbNO3 twice. So here 2 moles of this lead nitrate breaks into 2 moles of lead oxide and 4 moles of nitrogen dioxide gas along with oxygen gas also released. Okay, see here, this is lead nitrate. When this lead nitrate is heated, okay, this lead nitrate absorbs heat energy and it breaks into lead oxide and nitrogen dioxide and oxygen. Okay, so see here, when this lead nitrate is heated, okay, when lead nitrate is taken in a test tube and it is heated, will absorb brown fumes, brown colored, will absorb brown color fumes. This brown color fumes is nothing but it is nitrogen dioxide gas. When this lead nitrate is heated, brown colored fumes is released. Okay, that brown colored fumes is nothing but they are the fumes of nitrogen dioxide gas. Okay, along with this a brown precipitate is formed. This brown precipitate is nothing but it is lead oxide. Okay, PbO. Along with this release of nitrogen dioxide, oxygen gas also released. Okay, this is the decomposition of lead nitrate, and this decomposition of lead nitrate is initiated by absorbing the heat energy. Okay, here heat energy is absorbed by the reactant to break into simpler products. So it is one more example for the thermal decomposition reaction. Now we will see one more example, decomposition of ferrous sulfate. Okay, what is the chemical formula of ferrous sulfate? Ferrous means iron, Fe, sulfate means SO4. Okay, ferrous sulfate. Here 2 moles of ferrous sulfate. It is a solid. When it is heated, when ferrous sulfate is heated, it breaks into iron oxide, sulfur dioxide and sulfur trioxide gas. Okay, this is iron oxide. Along with formation of this iron oxide, here sulfur dioxide gas, also sulfur trioxide gas is released. Okay, see here this single reactant on heating or on absorbing the heat energy, it breaks into simpler products, that is iron oxide, sulfur dioxide and sulfur trioxide. Okay, therefore it is also an example for the thermal decomposition reaction, because here decomposition of this ferrous sulfate takes place due to the absorption of heat energy. Okay, this is the thermal decomposition reaction. Okay children, now we will move to the photochemical decomposition reaction. Decomposition reaction. Okay children, see here, this is watch glass. I will take one watch glass. This is watch glass. In this I have placed silver chloride. Okay, now I will in this watch glass I will place silver chloride. This silver chloride is white powder. This silver chloride is white powder. Okay, in another watch glass and take another watch glass, and in that I'll place silver bromide. Okay, this is pale yellow powder. Okay, in another watch glass I will take silver iodide. Okay, it is yellow powder. Okay, see here, in one watch glass I have taken silver chloride, in another watch glass I have taken silver bromide. Okay, actually this silver chloride is white powder, the silver bromide is pale yellow powder, and the silver iodide is yellow powder. Okay, now all these three watch glass are exposed to sunlight. Okay, all this okay, when all these three watch glass they are exposed to all these three compounds are exposed to the sunlight, the color of the silver chloride changes from white to gray. And here also this silver bromide, okay, on exposing to the sunlight after some time, pale color of this powder. Okay, this silver bromide after some time, when it is exposed to the sunlight after some time, pale yellow color of the silver bromide changes into gray. Similarly, the silver iodide, okay, on exposing to sunlight after some time, its yellow color, okay, yellow colored powder changes into gray. Okay, here actually now we will write the chemical reactions. We will write the chemical equations for the chemical reactions involved here. Okay, see here silver chloride, it is a white powder when it is exposed to sunlight. Okay, this silver chloride absorbs the sunlight. Okay, sunlight, it absorbs the sunlight and it decomposes into silver and chlorine gas. Okay, this is silver chloride. Actually, it is a white colored powder when it is exposed to sunlight. Okay, here sunlight, we will just this sunlight is, we will write like this, H mu means sunlight, light energy. Okay, on exposing to sunlight, this silver chloride decomposes into silver and chlorine gas. Okay, actually the gray colored absorbed here is nothing but this gray colored. Okay, this gray colored is absorbed due to the formation of this silver atoms. Okay, it is due to the formation of this free silver atoms. Okay, now we will write chemical equation for this one. Here silver bromide. Okay, silver bromide, actually it is pale yellow powder. Okay, when it is exposed to sunlight, it absorbs the light energy and it decomposes into, it is also solid, okay, it decomposes into silver and chlorine gas. Again, this silver is gray in color, therefore when this silver bromide is exposed to sunlight, pale yellow powder changes into gray color. Okay, again here also silver iodide, again it is yellow powder. On exposing to sunlight, it decomposes into silver and chlorine gas. So again this is gray color is due to the formation of this silver atoms. So see here, these are the 3 examples for the photochemical reactions. Okay, then what is photochemical reaction? Okay, the reaction in which chemical compound breaks into simpler products by absorbing light energy is called photochemical decomposition reaction. See here, the word photo means sunlight. Okay, photochemical decomposition, due to the absorption of the light energy, here decomposition of the chemical substance takes place. Okay, also observe here in thermal decomposition, thermal means heat energy. Okay, thermal means heat energy and photo means light energy. Okay, now next we will study the electrodecomposition reaction. Electrodecomposition reaction. Okay, the reaction, what is electrodecomposition reaction? Okay, see here in the word electrodecomposition. Okay, electro means electricity. Here decomposition of the chemical substance takes place by absorbing the electric energy. Okay, so the reaction in which a chemical compound breaks into simpler products by absorbing electric energy is known as electrodecomposition reaction. Electrodecomposition reaction. Okay. Example for this kind of decomposition reaction is electrolysis of water. Okay, electrolysis of water. Okay, see here, electro means electricity, lysis means breaking. Okay, here water breaks into hydrogen and oxygen by absorbing electricity or electric energy. Okay, so electrolysis of water is an example for electrodecomposition reaction. Okay, so now we will perform one activity. Before performing activity, let me write the chemical equation for the electrolysis of water. Okay, this is water on providing electric energy. This water breaks or decomposes into hydrogen gas and oxygen gas. Okay, so let us perform an activity. Now we will take a jug or a plastic beaker. This is plastic beaker. These are graphite rods. And they are connected to the two terminals of battery via switch. This is battery. This is switch. Okay, and here these two are filled with water. And it is also, this plastic beaker also filled with water. Okay, water. See here, this graphite rod is taken as anode. Anode means positively charged electrode. Okay, and this is taken as cathode. Okay, cathode means negatively charged electrode. Okay, remember that cation and anion are different from cathode and anode. Okay, cations means positive ion, positively charged ion. Anion means negatively charged ion. Okay, whereas cathode means negatively charged electrode. See the difference here. Whereas anode means positively charged electrode. Electrode is nothing but it is a graphite rod. Here we have taken graphite rod as a electrodes. Okay, the graphite rod which is negatively charged is taken as cathode. See here, this is cathode, and another graphite rod which is positively charged, okay, that is taken as anode. Okay, cation and anion are entirely different from the cathode and anode. Okay, see here, so here we have taken one plastic beaker. In that we have placed two electrodes, one is cathode and another one is anode. Okay, these electrodes are made up of graphite rods, and this is filled with the water, and these two terminals of these two electrodes, anode and cathode, are connected to the two terminals of battery. Okay, when switch is on, electricity will pass through these two electrodes, and here water is present. Okay, inside this beaker water is present. Okay, when electricity is provided or electricity is passed, this water present inside this beaker, it breaks into hydrogen gas and oxygen gas. Okay, so here water breaks into hydrogen gas and oxygen gas by passage of electricity. Okay, by absorbing the electric energy, this water breaks into hydrogen gas and oxygen gas. Okay, hydrogen gas is collected in cathode tube. Okay, this is our cathode at the cathode side. Okay, here hydrogen gas is collected, and here oxygen gas is collected. Okay, here the quantity of the volume of the hydrogen gas released is twice the oxygen gas, because see the proportion here. In one water molecule, if you take one water molecule, in one water molecule two hydrogen atoms are present, one oxygen atom is present. Therefore, because of this ratio in water, okay, here hydrogen, if you see the ratio of hydrogen and hydrogen oxygen, hydrogen is 2. Okay, number of hydrogen atoms is 2, whereas this oxygen is 1. Here ratio is 2:1. Therefore, here after electrolysis of water, the hydrogen and oxygen gas are released, and their ratio is 2:1, or hydrogen gas released is twice the oxygen gas. Okay, this is what electrolysis of the water. Here water breaks into oxygen and hydrogen gas by absorbing the electric energy. So it is electrodecomposition reaction. Okay, now we will see another kind of reaction, analysis reaction. Okay, what is analysis reaction? Okay, analysis reaction is the decomposition reaction. Is the decomposition reaction, or just we can say that decomposition reaction in which a compound breaks into its element, elements is known as analysis reaction. Is known as analysis reaction. Okay, so decomposition reaction in which a compound breaks into its element is known as analysis reaction. Now we will understand this kind of reaction with examples. See here, decomposition of mercuric oxide. Chemical formula of the mercuric oxide is HgO. Here 2 moles of mercuric oxide heated. On heating this mercuric oxide, it breaks into mercury and oxygen gas. Okay. Here, see here, this is a compound. Mercuric oxide is a compound. It is made up of 2 elements, mercury and oxygen. When this compound is heated, okay, it breaks into mercury and oxygen. Okay, they are the 2 elements. Okay, on observing heat energy, this compound breaks into its element. Therefore, it is an example for analysis reaction. We will see one more example. Decomposition of hydrogen iodide. Okay, chemical formula of hydrogen iodide is Hi. When it is heated, okay, it breaks into hydrogen gas and oxygen gas. Okay, this is hydrogen iodide compound, and this compound is made up of 2 elements, hydrogen and iodide. On heating, it absorbs the heat energy and it breaks into its element, that is hydrogen gas and oxygen gas. Okay, this is about the analysis reaction. Okay children, so far we have learned the types of chemical reactions. Among them we have learned 2 types of chemical reactions, that is combination reaction and decomposition reaction. In a decomposition reaction, further we learned the types of decomposition reaction, that is thermal decomposition, photochemical decomposition, electrodecomposition reaction, and also we learned another kind of decomposition reaction, that is analysis reaction. Okay children, in next class we will learn remaining 3 types of chemical reactions.